We'll start with the session. Welcome, Dr. Amitav Chaudhary, sir.
Thank you.
Okay. So, before starting with the session, I would like to give a brief introduction of Dr. Amitav, sir. Sir is working as an assistant professor in the School of Computer Science, University of Petroleum and Energy Studies, Dehradun, India. He did his PhD from India Institute of Engineering Science and Technology, Shibpur, and Master of Technology from Jadavpur University, Kolkata. Sir has more than 9 years of experience in teaching and 2 years in research work. Sir is serving as a reviewer of IEEE Biomedical Transaction and Medical and Biological Engineering in Computing. He is a member of IEEE UP section and Institute of Engineers, India. Currently, Sir is associated with Cluster Computing as a guest editor, and his area of research interest are computational geometry in the field of micromechanical modeling, pattern recognition, character recognition, and machine learning. So, welcome, sir, to this 5 days online workshop on data mining and its application.
Thank you. Thank you, Dr. Hema, for this brief introduction. First of all, I wish all the female participants and the organizing team a great Women's Day. And fortunately, all the coordinator of this event are also the females. So I'm really thankful to all of you, and also thankful to Afrin ma'am and you and all the entire organizing committee to giving me this opportunity to share my knowledge in front of the participants. So as this is a 1 hour schedule, so without wasting much time, I just directly jump to the session. Uh, just let me know whether this screen is visible or not. Is the screen is visible? Please inform.
No, sir. You cannot see the screen.
Okay, just a minute. Now it is visible?
No, sir. It is
Yes,
not.
sir, it is.
It is?
Yes, ma'am, it is.
It is.
Okay, sir. I am not able to see. Okay, sir.
Is it visible?
Yes, sir, it is visible.
Yes, sir, it is visible.
Okay, thank you. Thank you for your responses. Okay, as it is written here, the today's topic is a neural network and their application in data science. So already Hema ma'am introduced myself. Still, I have just give a small introduction about me. That's I am Amitav Chaudhary. I'm working as a assistant professor in the Department of Informatics, School of Computer Science, University of Petroleum and Energy Studies. And this is the web page. If you want to collect the content and the other resources of today's session, you can download from this web page of mine. Okay, so without wasting our time, let's directly jump to the discussion. Here are the brief plan of action that I'm going to discuss today. Number one is what is neuron, then the activation function, then how do a neural network works, followed by how neural network learns. Also, we are talking about gradient descent and backpropagation and implementation of neural network using Jupyter Notebook, that is a Python programming. Okay, now if we talking about the neuron, so it is from our basic understanding of biological science that neurons are the fundamental units of brain, and these are responsible for receiving sensory inputs from the external world, for sending motor commands to our muscles, and for transforming the relying the electrical signals at every step in between, is not it? So obviously from our basic understanding that we know there's a major two parts of human neuron, that is, one is axon, another is the dendrite. So axon is this long uh, thin structure in which axon proteins are generated, transmitting parts of the neuron, and after initiation axon proteins travel down axon to the release of a neurotransmitter. So that means we can simply say axon are the transmitter of the signal for a neuron. Whereas the other hand, dendrite are the receiving part of the neuron. It receives the synaptic inputs from axon with the sum of total dendritic input determining whether the neurons will fire an axon potential or not. So simply dendrites are the receiver of signals for neurons. So that is the basic elementary neuroscience concepts, but now we are leaving these neuroscience concepts and moving towards the technology. So suppose this is a neuron denoted by a green circle, and this is sometimes known as nodes. So neurons get some signals from various sensor. Okay, so these are the input six sensors. So for us, for human brain, the input sensors are like tongue, eyes, ear, nose. So here the input signals are coming from, say for example, if you're talking about to calculate the price of a building, so maybe the size, there is how much square feet the building is, how old the building is, where the location of the building. So these are the simply inputs to calculate the price of a neural price of a I mean to say that building. So what is our aim? Our aim is to, based on the biological understanding of neuron, can we able to design one more uh, application which are very helpful to solve the data mining techniques, or in data science how we use this concept of neural network. But obviously this is not a new technique, this is a very old. In 1953 this is the neural network concept is already uh, discussed at very beginning. Now we move towards the deep learning concepts, where we are talking about the convolutional neural networks. But whatever it is, whether it is an artificial neural network, whether it is a convolutional neural network, the basic understanding of neural network has remained same. And our aim is to understand how we can implement a neural network from a scratch. So that is the main purpose of this FDPO as well. Now, based on these input signals, we have to calculate one output signal. So here you can see, based on 3 input signal, 1 output signal going to be generated, is not it? So this is one of the simple structure. Now discuss about the color combination. See, the color combination for neuron is, say, blue, say green, whereas for inputs, say yellow, and for output signal we assuming this color concept as red. Okay. Now, what is this arrow line means? What is this arrow line means? So these are nothing but the synapse. So through which the signals come to the neuron. Okay, and based on these new signals, uh, output going to be generated. Okay, so again, if you're talking about the simply based on the shape of a fruit and the taste of a fruit, the color of a fruit, we have to choose that what is the fruit is. Okay, so if it is a round shape and color is red and taste is a bit acidic, then we can say, okay, this might be apple in some cases. Okay, so this is the concept of neural network. One more time. Now, when you're talking about these input values, so these input values are nothing but the independent variables. So, obviously, independent, we know the concept of independent variables. That means these are not dependent to each other. And when you're talking about these independent variables, we have to use some method that is known as standardizations. Sometimes it is also known as normalizations. So, depending on the situations, we have to depending on the situation, depending on the different values of the input variable, we have to standardize it. This is basic statistical methods. So why standardization or normalization is required to normalize the values so that the scale we can find out the same scale of each values. Now, when you're talking about the outputs, so these outputs can be continuous. So what is the meaning of continuous? Say for example, if you want to calculate the price of a building based on the the size, based on the location, or based on the how old, that means based on the ages. So if size, location and age factor are three independent parameters to calculate the price, so but the output could be one, that is the what is the price, say whether it is a 20 lakhs or it is 40 lakhs or something like that. Now, there is another output could be possible, that is the binary. So again, it is the one based output, but the output based on yes or no, whether it is a cat or dog. Simply, as if you have a if you have two images that you have to say the particular image either cat or dog or not, simply. So this is a binary, that means two existence are there. So out of two this existence we have to choose a single one. So again the output become a single objective output. And final one is third one is the categorical. So what is the meaning of categorical? Categorical means there are multiple number of outputs. Say instead of only y, we have to calculate say y1, y2 or y3. So say for example, in between cat, dog and horse, we have to choose any number of category. So how we can implement this? Okay, so these are the various output considerations based on the various applications. So continuous, binary and categorical are the output values of, from a network. Now we have to talk about one more important terminology, which is known as weights. So these weights are external value which is very close to zero but not zero. This weights value is very close to zero but not exactly zero, and these weights are going to be manipulate those inputs value. So when it's talking about when we talking about the neurons, so these weight value are multiplied with the input value, and then it gets the computational uh, mm, uh, process. Now, how this weight can be multiplied? To do this, we need some observations how this neuron acts based on the input values, because these input values are nothing but the numerical values, say 10, 20 or 10 lakhs, 20 lakhs or whatever the value is. And weight is also a numerical value which is not fixed but random. uh, so based on this numerical value, what is this what or how this neuron uh, works, that is the main aim of discussion. Now, to do this, there is a concept named activation functions. So before go to the activation functions, we must talking about that how this weights and uh, inputs are associated within this neuron. So it is nothing but the summation of input value into the weights. So if you consider this, there are three input value, as there are m inputs value, so we choose 1 to m, so wixi, where wi is the number of weights and xi is the number of input values. So simply, if from this figure, if we choose these yellow circles are x1, x2 and x3, having weights of w1, w2 and w3, so we can write like, say, x1 w1 plus x2 w2 plus x3 w3. Okay, so this is what the neuron get actually. So now what next? So this is, it gets the value, say w1 x1, w2 x2 and w3 x3, the summation of this. So obviously whatever the value we get, it is also a numeric value, and one bias value is sometimes added with this. So bias is to adjust the next learning process. So we will discuss about bias in later section. Now, second thing is the optimize, that is the activation function. So here phi describe the activation functions. So based on the input value, which activation function we should choose, so that in my third step it gives the output. So there are uh, four different activation functions are available. Number one is a threshold. So if you're talking about this threshold function, for this wixi, it is either 1 or 0. So you can see it is either 1 or it could be a 0. So uh, for any uh, classification or any prediction process, if you need the output, say a strictly 1 or 0, then threshold function is very much useful. Now there is one most important sigmoid is the most important activation function, which is the 1 upon 1 plus e to the power minus x, where x is the total number of inputs. Okay, so here also it gives the result 0 to 1, but here there is an opportunity to calculate, say for example, if you get the probability of any that how much it chance to closer to 1. So for example, if we get a value instead of 1, if I get a value, say 0.92, so we can say, okay, as 0.92 is very closer to 1, so we can choose this is a, say for example, our yes particular things. Yes means, say for example, if we are going to check whether a given picture belongs to a dog or cat. So if the probability value is 9.92. So in that case we can say, okay, 0.92, which is very similar to 1, and if we say that 1 belongs to cat, so we can say, okay, it's 0.92, so that means it belongs to 1. And as we say that 1 is equal to a cat, so we can consider this image of a particular image uh, uh, belongs to a cat category. Okay, so this is the sigmoid, and this is the advantage of sigmoid over threshold functions. Okay, now next one is a rectifier, or it is one of the most commonly used function, which is based on the maximum of max function among the input variables available. So generally we use this combination, that ReLU, linear rectifier unit, and the sigmoid or sigmoidal activation function generally used. And one more activation function we can find, that is the hyperbolic tangent, which is 1 minus e to the power minus 2x to upon 1 plus e to the power minus 2x. So here we get a wider range of uh, values, but in our case we are getting these values from generally rectifier units and the sigmoids. Now if you want to learn more about this activation function, this is a link, is you can find the more about these activation functions, and how these activation functions are very much useful and all that. uh, so for example, in various cases that we discuss, so ReLU we use to compute the hidden layers, whereas the sigmoid function is basically we try to use when we're talking about the output layers. Okay, so I think as of now we don't have any difficulties. So if we recall the things, first we have to calculate the neurons, then based on the inputs we have to associate, or we have to draw some weights. So weights and inputs are multiplied together, and there is an activation function which computes the results, and which pass to the next layer, and these layers are the output layer. Based on the activation function, output layer gives you the uh, results. So here input layer is this is the first layer, second layer, or three layer architecture we can say. uh, Input layer is also the input index or input parameter. The hidden layer, this one hidden layer is there, which computes the uh, xi into wi values, and based on the ReLU activation function, it passes the result to the next layer, which is the output layer. In output layer we connect these all four information. From these four information we again a single observation output we can get, say whether it is a cat or dog or not, or something like that. Okay, now let's move on with an example that how do neural network works. So for example, there is a petal, two type of flower is there. So the length of petal and the uh, width of petal has been calculated, and these flower are two types. One is either a red type flower or a blue type flower. So there is some observation we have calculated, that if the petal length is 3 centimeter or whatever the measurement unit, and petal width is 1.5 centimeter or whatever the measurement unit, then we must say this is belongs to a red category of flower. Similarly, if it is 2 and 1, then we must say it is a blue category of flower. And there are some observation, but finally suppose we have that 4.5 is the length and 1 is the width, then somehow we forget to calculate what is the color of this petal. Now, uh, from our basic understanding, we can draw some graphs. Based on the graph value, we can say, okay, what is the color for this missing uh, color or missing flower. That is one of the possibility, but again, the chance for this the acceptance of this accuracy, really big question mark. To, to do that, will neural networks very much helpful? So let's try to understand based on the neural network concepts. So far we have discussed that we can use some weights, we can input some numerical values based on weights and input values and other bias. Then we can have some uh, activation function, and then we get a single output. So let's try to assume that 1 stands for red and 0 stands for blue. So we said that if our result goes to 1, so then we can say that okay, this is belongs to red flower, or if it is 0, then we can say okay, it's a blue flower. So these are two inputs, length and width. The output will be the color. Again, the length of two inputs, we take the length is 2 and width is 1. Then what would be the color? So it is already given. So if length is 2 and width is 1, the color is blue. But first we try to train our system or the model or the network that what color it is, whether it is a blue or not. So what to do to solve this? Uh, as you can see that there is a 2 and 1 as a length and width, and we need to calculate this color. So we assume that there's a two weights, W1 and W2 has to be multiply with these two input values. So if we say that this would be the resultant, so it's talking about sigmoid, a single value going to be predicted. So sigmoid, the two color is the our model name or the network name is color. So it's having two inputs, one is length, another is width, and obviously we can say that's x into w1 or x1 into w1 plus x2 into w2 plus x2 x3 into w3 and so on. So that is simply nothing but the summation of xi to wi, where I is equal to 1 to m. Is not it? So we can calculate the sigmoid of this. So length into W1 plus width into W2 plus B. So B is nothing but the bias. So here length is 2, width is 1, and we assume this W2, W1, W2 and B value is the random value, and we choose this value to say 0.5, okay, for W1, say 0.2 to W2 and zero point 0.3 for B. And if you calculate this value, sigmoid means you get this, there's a numerical value, so it is nothing but 1 plus e to the power minus x. So here the x value means this is the x value. So if you calculate this formula, you get 0.82, so which is near to 1, which is means red value. But earlier we can see, so it's a red value, but we can see that this should be belongs to a blue one. So obviously my model is not works properly. But obviously you can see that this zero point 0.5 or zero point 0.2 or the W1 or W2 value or the B value, whichever it taken, that is randomly taken, so that is why it's gets some affected. Okay, so let's try to solve it uh, with example in neural network model, so that we can implement our first model using Python. Okay, okay. Just tell me whether this notebook is visible or not.
Yes, sir, it is visible.
Okay. Uh, let's change it to the petal problem. Okay. This is the name of this file, say for example a petal problem. So what we do, if obviously to do this, as we using Python programming, so you have to have a knowledge of Python programming. There is a uh, numerical library in Python, which is known as NumPy. So we create an alias NumPy as NP. So let's check whether it's execute or not. And then what is our aim? Our aim is to create a neural network and whose name is color, say for example. So we are going to define a function, say whose name is color. Okay, and it is a function. Okay, it takes 5 arguments. One is length, another is width, another is weight 1, another is weight 2, another is bias. Okay, now we have to calculate the sigmoid of it. So I write, say for example, we compute the numerical or arithmetic operation first. So it's something like say L into W1 plus uh, width into weight 2, that is the and the bias. Okay, and its returns, sorry, its returns return the sigmoid value of what, of z, obviously. So it is nothing but the it gives the sigmoid value of z. But here sigmoid, we have to define sigmoid because sigmoid is not an inbuilt function. So you have to define sigmoid, that how sigmoid works. So def sigmoid, it takes one argument, say x, and you can say return how sigmoid works. So it's return 1 upon 1 plus np dot exp, which is 1 plus 1 by e to the power, sorry, 1 by 1 plus e to the power minus x. So e to the power minus x. So this is how you can formulate it. Okay, so now execute it. So let's see. Okay, both the functions is defined, and then we have to calculate the random values. So how we calculate the random values? So again, using this numpy, we can calculate the random values. So np dot random dot random numbers. So if you write rand in, okay, so it's a function. So it's, if you execute it, it's generate a random numbers every time. If you execute it, it generates a random number. You can see, say now it's 0.34, it's on minus 0.14, it's 1, or sometimes it's generate different random numbers. Okay, so what we do, we choose a w1 is equal to this, uh, then w2, sorry, w2 is equal to this, and bias is equal to this. So we get three numbers. One is a w1, then next is w2, and third one is bias. Okay, so we calculate, we can able to calculate all these three values. So these are the random values, is not it? Now take one more sample through which we can check the color. So if I say color, and our input is length is 2 and output is 1, so let's see how it works. So what it say? So it's okay, sorry, obviously, because color having 5 parameters, so we pass only 2, so that is why it gives 3 arguments are missing. So obviously we have to pass w1, w2, and bias. Okay, so w1 collected from here, w2 collected from here, and b is our bias collected from here. So if you execute it, it's a 0.05. So 0.05, which is very close to 0. So we can say, okay, this is a blue color. So okay, in this case, our model say accurately correct. Whether our in case of when we choose a random value, say 0.5 to 0.3 for W1 and W2, and zero point 0.2 for bias, at that time the result is something different, but here the result is something different. We get that color is somehow uh, blue. Okay, that's very good. Let's talking about another case. Say for example, what happened the first color, say length is 3 and width is 1.5. so length is 3 and it is 1 point, width is 1.5. In this case, actually it should be, okay, see here it should be red color, but somehow it's again says the blue color. So our neural networks works, but it is not working properly. So we create our neural network, there's nothing wrong with this, but the output is not very much acceptable, is not it? So what is the problem behind this? So that is a concept, that how we trained our neural network. So here we just give some value, and based on these values we try to calculate the color, or calculate the outputs. So before do that, if we able to train our neural network, okay, if this x value or length value is this and width value is this, then you choose a red color, okay, or vice versa. uh, in case of blue flower. So we have to train the model, number one. Number two, we can see there is a huge difference. Say one is the color value for red. So we expect one but here we get 0.03. So that means from the actual to the predicted value is there is a huge difference, is not it? So we have how we get the maximum result. So if the result whatever we get it able to reduce the uh, this loss, error loss, or reduce the or minimize the error simply. So again, come back to the presentation so that we can mm, see that how we can uh, implement the same thing. So here two inputs are there again, input 1 and input 2, which is length and width. It's calculate the activation functions. Based on this activation function, it gives you the output. Now, instead saying this output as y, we are taking this as y hat, and y hat is nothing but uh, the predicted result. So y hat is nothing but the predicted result, and y is nothing but the actual result. Okay, so if you know your actual value and what is the predicted value, that the predicted value is calculated through your network, then if we able to minimize this error, how we calculate this error? To calculate this error, we have a loss cost function. This cost function is denoted as half of y minus y hat square. Okay, so if we see, somewhere there are so many cost functions available. One of the simplestly uses half of y minus y hat square. You can use only y minus y hat square, it doesn't matter. uh, so here you can see that based on this y and y hat value, we can calculate the cost function, and we say okay, there is a possibility you can change your weights or you can update your value. So how we do that? So there is a back concept, or we can say, if we able to, if you do not know that back propagation, and later in next slide I will going to discuss about back propagation. Here we just understand that if somehow we able to give this message or convey this message, okay, reduce the value of to get the 100% accuracy or closer to 100% accuracy, just to mitigate or the minimize the loss value. So how you calculate this loss value? Say y minus y hat square. So if you get this loss value, say for example x, then you have to convey this message to this uh, network, that okay, this layer, okay, reduce it. So now you have to pass the signal to this layer, and this signal again pass this message, okay, update these parameters or update this value, because we do not get the actual results, or there is a huge error we find. So next, again, it's going to be adjust the weight. So here the weights are going to be adjusted. So earlier say it is W1, W2. Now it is say W new 1 and W new 2. Okay, so this new 1, new 2 are nothing but the new weights which is going to be adjusted, because this input value, say this input value is 2, and for this it is 1. So length and width, uh, this is fixed, and this is not changeable. Okay, these are the independent variable. So this value of length is always already measured, this value, the width of the flower is already measured. We cannot change these two value. What value we can change? We can change or update the weight value. We can update the weight value. Okay, so how we update the weight value? If you able to give a signal that okay, based on this value, your weight should be updated. So that is the concept of back propagation also. Okay, so this is all about the how your neural networks learn. So it is when we talking about this architecture. So this is nothing but a feed forward propagation. So feed forward means whatever message or signal it have, it's forwarded uh, from the input source to the output source. But in case of mitigate the loss, or in terms of understand the each and individual data very well, we have to back propagate the network. This is one of the example. Okay. Um, I think it is clear. Now, most one of the important thing that is known as gradient descents. We have already discussed about back propagations. So gradient descent in nothing but the concept through which we can mitigate the loss or minimize the loss. So simply from this value, suppose we want to get a loss of minimize the loss. So here we can find that if you calculate the distance of this point with respect to this origin or this x-axis, you can find here it is huge, but here it is minimum. So we choose this point in case of gradient descent, is not it? So again, let's take an example to understand this gradient descent problem and back propagation problem. So before that example, I just want to mention that there are three type of gradient descent. One is batch gradient descent, where all the available data is injected at once to the model. Second one is stochastic gradient descent, where a single random sample is going to introduce each iteration. And mini batch gradient descent technique, which is a single random sample introduced on each iteration. So what is the difference between these two? Here a single output is going to be single input is going to be feeded, but here not a single random sample, a batch of samples are going to be hidden, whereas in case of batch gradient is a whole input data going to be fed to the network. So these are the three types of gradient descent techniques. One is batch gradient, stochastic gradient descent, and mini batch gradient descent. So we can see that we don't have much time. So let's take a small example to understand this gradient descent problem. Okay. Simply suppose your input values are 0, 1, 2, 3, 4, and you need an output of say 0, 6, 12, 18, and 24. So from our basic understanding or my understanding, that if we able to multiply this value with 6, we can get the output value. Okay, so but how your neural network understand that what should be the w value in this case? So this we to understand this gradient descent, we just take three values of w. Say first time it is 3, second time it is 6, and third time it is 9. So for example, when w is equal to 9, then w is equal to 3, then there is a for first input there is a no loss, but this in second input onwards there is a loss in everywhere, is not it? Now, if you're talking about w is equal to 6, again you can find for first iteration or first step there is a no loss. For second there is a no loss, because this is the output, actual output. This is your predicted output. So 100% accuracy in this case. Third one also you get this 100% accuracy. For fourth one also you get the 100% accuracy, whereas the fifth one also you get the 100% accuracy. Now what happen if we increase this w value one more time? Say w is equal to 9. For the first value it is remain same, but every all other cases again it's become changing, is not it? So obviously it's a problem. So how we get the value, or how we understand that which value should we taken. The W is equal to 3 should be taken, or W is equal to 6 should be taken, or W is equal to 9 should be taken. So simply we just plot the loss with respect to the weights. So there are three weights, 3, 6, and 9, and here we get three types of loss. One is uh, 36. It is 12 minus 6, that is equal to 6. 6 square is 36, is not it? Again, 12 minus 12, that is equal to 0, and again 12 minus 6, that is minus 6 square is equal to again 36. Okay, so we calculate the loss. So we take input parameter set 2. So input parameter set 2, the actual output should be 12. For if you take weight value as 3, the predicted output is 6. Uh, if you take W value as 6, the predicted output is 12. If you take W value as 9, predicted output as 18. So if you plot this, you can find 2 times 36 from here, and 1 is 12. So 12 is very near to 0. So that is the 6 is the uh, your weight. So if you take 6 weight, then your output is optimal. So we have to optimize our cost function. So our optimization of cost, the gradient descent is one of the technique which optimize your cost function. So through this you can understand that how you calculate the loss. So minimize the loss. So minimize the loss means higher accuracy. So if you able to minimize this loss, then it will gives you the higher accuracy. Okay, so I have already discussed about this back propagation technique. So back propagation is nothing but the way once you get the loss through how you get the input from this uh, cost function, and then you just pass the messages, update the uh, weights, and based on the weights you calculate the uh, activation function one more time and check it. Okay, so it is something like feed forward, then back propagation, then again feed forward, then again back propagation, again feed forward, and then maybe it's gives you the result perfectly. Okay, so this is how your model get trained and gives you a better result. Okay, so let's understand what we discussed today one by one. Number one, that we have to initialize the weights to smaller number which is very close to 0 but not 0. Number two, input the first observation of your database for the first time, first row into the input layer. Each feature is one input node. So if you have two input node like length and width, so that means two input parameter has to be passed. Step 3, you have to there is a forward propagation. Forward propagation means it goes to left to right. The neurons are activated in a way that the impact of each neuron's activation is limited by the weights of each layer. Now step 4 is used to propagate the activation until getting the predicted result y hat in our case. Next, in step 5, we have to compare the error in back propagation, uh, update the weights accordingly so that we can mitigate the result. Again, as we come from right to left, we have to move from left to right after updating the weight. And final step, repeat the step 1 to 5 and update the weights after each observation. So this is all about the neural network, basic neural network concepts. These are the references I have used. If you tell me, we can implement using, we can try to implement a basic neural network with the help of Python program, if time permit me. Otherwise, thank you. So if you have any question, you can ask me.
So participants, if you have any query, you can ask the sir.